Hi there, and welcome to this video lesson on finding the area of a circle. Now, if you haven't done already, I would watch the video lesson on finding the circumference of a circle, as that is going to teach you the basic skills that we're going to need for this lesson. Okay, so let's jump straight into it. If we want to find the area of a circle, we're going to need to know one formula. And that formula is that the area equals pi times by the radius squared. Area equals pi times the radius squared. And we remember that the radius is the distance from the centre to the outside. That's the radius. And we also remember that the diameter is the length from one edge through the centre all the way to the other edge. And there's the diameter. And that radius is half the diameter. So those are all the things we need to know. But the main thing is this formula. You will need to commit this to memory, but don't worry too much because it will get in there. The area equals pi times the radius squared. Okay, so let's have a look at this first question. Find the area of this circle. Now, with any circle question, the first thing I want you to do is write down the radius and the diameter. So we put R equals D equals. Now we can see in this question we've been given the length from the centre to the outside edge. Therefore that length there, 4 centimetres, is the radius. Okay, and if the diameter is double the radius, the diameter is going to be 8 centimetres. Okay, so whenever you see any circle question, the first thing I want you to do is write down the radius and the diameter. Always, always, always. It's a great habit to get into. Now, we're finding the area, so let's write down our area formula. So area equals pi times radius squared. Area equals pi times radius squared. And now we can substitute in our R value that we've seen from our circle into this formula. So our R value is 4, so we're going to be replacing that R with 4. So our new line is area equals pi times by 4 squared. Area equals pi times 4 squared. All we've done is replaced this R with a 4. And we get that from up here and from here. Okay? Now our next step is to take this equation a little bit further. So area equals pi times by, and what is 4 squared? 4 squared is 16. So area equals pi times 16. So all we've done from here to here is we've just squared the 4. Okay? And now we can type this into our calculator. And I went over how to find pi earlier. But if you have a Casio calculator, you press Shift, which is the top left. And then you press this button here that looks like times 10 to the power of x. And it should have a little pi and an E above it. And if you press Shift and then this button here, you'll end up with pi on the screen. Okay, so let's type that in. So 16, or rather pi times by 16. And we end up with 50.265 centimetres. And we know it's centimetres because we're working in centimetres from up here. Now in this lesson, we're going to work everything to one decimal place. So that means cutting it off there, having a look at this number, seeing if that's 5 or larger. It is. And if it is, we round this number up. So area equals 50.3 centimetres squared. I'm sorry, that's centimetres squared up there. Okay? Because its area is going to be centimetres squared. So the final answer for the area of this circle up here is 50.3 centimetres squared. And we do that by finding the radius and the diameter, writing out our equation, substituting in our radius, squaring our radius, and then typing it all into the calculator and finding it to one decimal place. So it's actually quite straightforward and methodical to find the area of a circle. So what I want you to do now is pause the video here, have a go at this left-hand example. Copy out the working for that left-hand example. Then have a go at this right-hand example and play the video once you're done, and I'll go through the answer with you. So pause the video here, copy out the working, have a go at the right one. Okay, fantastic. So we're finding the area. First things first, it's a circle question, so let's write down our radius and our diameter. So our radius and our diameter. Then we look at the question, we see which one we've been given. We've been given the length from the centre to the outside, therefore that is the radius. So our radius is 6 centimetres. Therefore our diameter is double that, so it must be 12 centimetres. Now our next step is to write out our formula for area. So area equals pi times by r squared. Area equals pi times r squared. And as you get older, that formula will never ever leave you. You'll be 60 years old, you'll be on your deathbed, and you'll still remember area equals pi r squared. Okay? Now we substitute in our r value for our r value. So area equals pi times by 6 squared. Now our next step is to actually square the 6, so pi times by 36, because that's 6 squared. Now our next step is to type this into a calculator. Let's just move that out of the way. So if we type that into a calculator, pi times by 36, we end up with 113.097, and it's centimetres squared because it's area and we're working in centimetres, so centimetres squared. Now let's take this to one decimal place, so we cut it off there. We have a look, is that number larger than 5 or larger? Yes it is, so we round this number up. So our final area is 113.1 centimetres squared. And that's our final area. So if you got that, fantastic. Well done. Give yourself some ticks like that. Good. Okay. Let's have a look at this second example down here. So finding the area. Now it's a circle question, so we always put down our radius and our diameter. Always put down our radius and diameter. Then we look at our question and see what we've been given. Well, this time we've been given the length that goes from one edge through the centre all the way over to the other edge. So that means that is the diameter. So our 6 metres is the diameter. So what's our radius? Our radius is going to be half that, so that's 3 metres. Okay? Now we're finding the area, so we write down our area formula. So area equals pi times by r squared. Pi times by r squared. Now our next step is to substitute in our r value for our r. So we have area equals pi times by 3 squared. Pi times by 3 squared. Now our next step is to actually square our r3, square our r value. So it's pi times by 9 because that's 3 squared. And now we type it into a calculator. So pi times by 9 equals 28.274 metres squared, because it's area, so it must be squared, and we're working in metres because we can see up there. Okay? And like everything in this lesson, we're working to one decimal place. So we look at this number here, see if that's 5 or larger. Yes, it is. So we round this number up. So the area to one decimal place is 28.3 metres squared. And that's our final answer. Okay? So we do it exactly the same method. We find our radius, find our diameter. We write down our equation. We substitute in our r value. We square that r value. We type it into a calculator, and then we find it to one decimal place. Exactly the same. The only difference with this question is, as opposed to being given the radius first, we've been given the diameter. But we can work that out because the radius is half the diameter. Okay, so pause the video here, copy out the working for this left-hand example, and then have a go at this right-hand example and play the video once you're done, and I'll go through it with you. Okay, fantastic. Right, circle question, radius, diameter. That's the first thing we always do. What have we been given? Well, we've been given the length that goes from here through the centre all the way to the other side. We've been given the diameter. So our diameter is 10 meters. Our radius is half our diameter, so our radius is 5 meters. Okay, grand. Let's write out, we're finding the area, so let's write out our area equation. So area equals pi times by r squared. Now let's substitute in our r value. So area equals pi times by 5 squared. Now let's square our r value, let's square our 5. So area equals pi times by 25. Fantastic. Now let's type that into a calculator. So pi times by 25 gives us 78.539539. Fantastic. And now we're working to one decimal place, so we cut it off there and we look, is this number 5 or larger? No, it's not. So we keep this number the same. So our final area to one decimal place is 78.5 meters squared. Because it's area, so it's squared, and we're working in meters, so it's meters squared. Fantastic. If you got that as your final answer, well done. Give yourself some ticks. Let's give it a red pen. Well done. Very good. Very, very good. Okay, let's look at our third and final example. Okay. Our third and final example is slightly different because we've been given decimal places as the radius, but that is not a problem at all. We can just work out exactly the same as we would normally. So, radius, diameter. What have we been given? We've been given from the centre to one edge. We've been given the radius. So let's put 2.5 centimetres. Therefore, our diameter is double that. Our diameter is 5 centimetres. Now, it is worth noting that the radius and the diameter can be in absolutely any orientation. So we could have a radius that goes from there to there, or there to there, kind of like that. Not as wonky as that, but straight. So I've kept it simple and had it always going to the right or straight across horizontally, but they could go at any angle and any orientation. So that is something you want to keep an eye out for. So let's just get rid of those. Okay, we're finding the area. So let's write our area equation. So area equals pi times by r squared. Now let's substitute in our r value. So area equals pi times by 2.5 squared. Okay. Now let's actually square our 2.5. And so you might have to get a calculator for this. And if you do, you end up with pi times by 6.25. Okay. Now let's type that whole thing into our calculator to see what we get. So pi times by 6.25. And if you do, you end up with 19.635 centimetres squared. We're working in centimetres and it's area, so it's got to be squared. Okay, let's work it to one decimal place, so we cut it off there. We have a look, is this number 5 or larger? No, it's not, so this number stays the same. So our final area to one decimal place is 19.6 centimetres squared. And that's our final answer. Okay, so this is exactly the same as any of the other ones we've done, just we've been given a decimal place as the radius, and that's absolutely fine. We can work with that. We could probably be given any number as a radius, and we can work with it. Okay, so pause the video here, copy out the working for this left-hand example, then have a go at this right-hand example, and play the video once you're done, and I'll go through it. Okay, let's go through it. So, circle question, radius, diameter. First thing, always. What have we been given? We've been given the length that goes from the centre to the outside. We've been given the radius. So our radius is 3.5 centimetres. Therefore, our diameter is double that. Our diameter is 7 centimetres. Okay? We're finding the area. So we write out our area equation. Area equals pi times by r squared. Then we substitute in our r value, so area equals pi times by 3.5 squared. Fantastic. And then we actually square our 3.5. And if you do, you get 12.25. So our area is pi times by 12.25, like that. Now let's type that all into a calculator. And if you do, you end up with the area equals 38.485 centimetres squared. It's area, so it's squared, and we're working in centimetres, so it's centimetres squared. Now let's figure it out to one decimal place, so we cut it off there. We have a look, is this number 5 or larger? Yes it is, so we round this one up. So our final area to one decimal place is 38.5 centimetres squared. And that's our final answer. If you got that, fantastic. Give yourself some ticks. Well done. Well done. Okay, so what I've got down here is 4 checks for you to do and 1 extension. So we're finding the area of all of these. Make sure you've got your units right and make sure you're squaring right. That's the key thing. And make sure you're figuring whether you've been given the radius or the diameter, because that's going to affect your answer. And what I've also done is I've given you 1 extension question on there, and that is a semicircle. So you're going to have to use your brains to figure out the area of that. It's a nice little extension for those that are feeling up to it. Okay, so pause the video here, have a go at those 3 checks, and then possibly the extension, and then play the video once you're done. Okay, let's go through these. So I've just put the first question down here just to save us a little bit of space. So hopefully we can all pretty much figure this one out by now. So we do our radius and our diameter. We see what have we been given. Where's my little pen gone? There you go. What have we been given? We've been given from the centre to the outside. We've been given the radius. So our radius is 9 centimetres. And our diameter has to be double that, so our diameter is 18 centimetres. Okay, we're finding the area, so we write down that equation. Area equals pi times by r squared. We substitute in our r, so area equals pi times by 9 squared. Now we square our 9, we square our r value, so area equals pi times by 81. And now we type that into a calculator. So pi times by 81 gives us 254.469 centimetres squared. It's squared because we're area and we're working in centimetres. Now let's take that to one decimal place. So we cut it there. Is that 5 or larger? Yes it is, so we round that one up. So our final area to one decimal place is 254.5 centimetres squared. That's our final answer. If you got that, fantastic. Give yourself some ticks like that. Well done. Okay, let's have a look at this second example up here. So first things first, radius and diameter. Then we look at our question and see what we've been given. Well, we've been given the length that goes from one edge through the centre all the way to the other edge. So we've been given the diameter. So our diameter is 22 centimetres. Our radius is going to be half that. So our radius is going to be 11 centimetres. Now, we're finding the area. So let's write down our area equation. So area equals pi times by r squared. Let's substitute in our r value, so area equals pi times by 11 squared. Let's square 11, so area equals pi times by 121. Then let's type that into our calculator, so pi times 121. And if we do, we get an area of 380.133. And it's centimetres squared. Squared because it's an area, centimetres because we're working in centimetres. Let's round this to one decimal place, so we cut it off there. We see, is this number 5 or larger? No, it's not, so this number stays the same. Area equals 380.1 centimetres squared. That's your final answer. If you got that, fantastic. Give yourself some ticks. Well done. Okay, let's have a look at the third example. This might be a bit of a squeeze. So radius and diameter, always write that down. Let's see what we've been given. We've been given from the centre to the outside edge, therefore we've been given the radius. So radius is 5.5 metres, therefore our diameter is 11 metres. Let's write out our equation. So area equals pi times by r squared. Let's substitute in our r. So area equals pi times by 5.5 squared. Let's do 5.5 squared. So area equals, oh, there's 3 there. Let's get rid of that. Area equals pi times by 30.25. 30.25, and then if we type that into a calculator, so pi times by 30.25 gives us 95.033 meters squared because it's area, meters because we're working in meters. Let's find that to one decimal place, so we cut it off there. We look, is that number 5 or larger? No, it isn't, so this number stays the same. So our final answer to one decimal place is 95.0 meters squared. And that's our final answer. If you got that, fantastic. Give yourself some ticks. Well done. So that's the 3 checks. Let's have a look at that extension. Now, this extension is really interesting because as opposed to being given a whole circle, we've been given a semicircle, a half circle. So what we could do is we could just imagine that we've been given the whole circle and then divide the area by 2 to get the area of this semicircle. So that's how I'm going to do it. I'm going to find the area of the whole circle, and then at the very end, I'm going to divide it by 2. So imagine that's a whole circle. It's a circle question. So the first thing we do is radius and diameter. What have we been given? Well, we've been given the length from the centre to the outside edge. Therefore, we've been given the radius. So our radius is 3 centimetres. Our diameter is 6 centimetres. Okay? So now let's work out the area. So area equals pi times by r squared. Area equals pi times by 3 squared. Area equals pi times by 9. Area equals, now this is when we type it into a calculator, pi times by 9 gives us 28.274, and it's centimetres squared. Squared because it's an area, centimetres because we're working in centimetres. Now this is the point where I'm going to divide everything by 2 because this is the area of the whole circle and we want the area of the half circle, so we need to divide by 2. So area divided by 2 gives us, if we just do that on our calculator, gives us 14.137 centimetres squared. So that's the area of the semicircle. Let's take that to one decimal place, so we cut it off there. We see, is this number 5 or larger? No, it's not, so this number stays the same. So area of semicircle equals 14.1 centimetres squared. And that's our final answer. If you manage to come to that, that is fantastic. Well done. Give yourself some ticks. Very, very well done. Okay, so that is the lesson on finding the area of circles. What I suggest you do is have a look in the description to find the link for the worksheet that I've given you, to the Corbett Maths worksheet. And it's a really, really good worksheet. And what I would do is I would do a question, then do an answer. So do question 1A, check the answer. 1B, check the answer. 1C, check the answer. And just go through all the questions to really consolidate the knowledge that we've just worked on today. Yeah, so if you can do all that, that's a really good foundation for the future where we look at volume of cylinders and any question that is just a bit out there and not directly, well, it's related to circles, but it's not a direct circle. They're not specifically asking you to find the area, but that might be involved in some way. Okay, so well done today. Have a look at that worksheet, and hopefully I'll see you in the next lesson.